Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are starting example number 19 from this miscellaneous exercise. Observe the given condition in the example. Here it is given to us that if the slope of one of the line given by this homogeneous equation is square the slope of another line. So we know that homogeneous equation represent pair of lines. Both the line passes through what? Origin. And slope of one of the line is square the slope of another line. This slope of two lines satisfies this condition that slope of one line is equal to square of slope of another line. Using this condition, we have to show that value of a square b plus ab square plus 8h cube is equal to 6abh. So here, since the example is related with what? Slope. So denote the slope of one line by m1 and slope of another line by what? m2. So we are supposing that let m1 and m2 be the slope of the line represented by this homogeneous equation. So if m1 and m2 are the slopes of the line represented by this equation, so we can say that m1 plus m2 will be equals to minus 2h upon b. Let us denote it by equation number first. Again, what result we are getting? m1 into m2 is equals to a upon b. Denote this result by equation number second. Also, what is the given condition? It is given to us that slope of one line is square the slope of another line. Means m1 is equal to square the slope of m2. This is the given condition in the example. Denote, so this is given condition in the example. So now I am substituting value of m1 is equal to m2 square in this equation second. Let us see what we will get here. So put m1 is equal to m2 square in equation number first, sorry, in equation number second. See what we are getting. I am replacing this m1 by m2 square into this m2, keep it as it is. On this side a upon b, keep it as it is, which implies that m2 square into m2 will be cube of m2 divided by a upon, keep this side a upon b as it is. In this way we have got the value of m2 cube. Again, see here, what is the given condition? m1 is equal to m2 square. So m1 is equal to m2 square. If we are taking cube on both sides, let us see what we will get here. So take cube on both sides. See what we are getting. On this side we will get m1 cube, and if we are taking cube of this side we will get m2 cube. Keep this square as it is. Just simply we have taken cube on both sides. So now what is the value of m2 cube is equal to a upon b. So we are replacing this m2 cube by a upon b. Keep this square as it is. Just simply we have substituted the value of what? m2 cube. What is the value of m2 cube? Is equal to a upon b. So what result we are getting? This implies that m1 cube will be equal to a upon b whole bracket square can be written as a square upon b square. In this way we have got the value of m1 cube also, value of m2 cube also, and even the sum of slope and product of slope is also known to us. Now we will focus on our required result. In our required result, since the term of cube also appears, so that's why we are using one identity which we have studied in algebra in our earlier classes. What is that identity? So m1 plus m2 whole bracket cube will be equals to m1 cube plus m2 cube plus 3m1 m2 into m1 plus m2, isn't it? So which identity we have seen? A plus b whole bracket cube is equal to what? A cube plus b cube plus 3ab into a plus b. And why we are using this identity? Because in this identity term of sum and product appears, and we will have the values of sum and product. Even to apply this identity we will require the value of m1 cube and m2 cube also. That's why already we have obtained this value m1 cube and what? m2 cube. Now substitute these values in this equation. So m1 plus m2, I am replacing m1 plus m2 by its value minus 2h upon b, minus 2h upon b. Keep this cube as it is. On this side m1 cube can be replaced by its value. Observe what is the value of m1 cube is equal to a square divided by b square plus m2 cube, value of m2 cube is equal to a upon b, plus 3, keep it as it is, m1 into m2 is equal to a upon b, and m1 plus m2 is what? Minus 2h upon b. After substituting these values in this equation, simplifying this equation, now we are trying to get our required result. So here, what is cube of minus 2h will be minus 8h cube. In the denominator, cube of b will be equal to b cube. On this side, what is the denominator? B cube. So that's why on this side also we are trying to get b cube in the denominator. To get b cube in the denominator, we have to multiply to numerator and denominator by b. So what we are getting in the numerator? A square b, and in the denominator b cube. Here already b is in the denominator. We will require b cube in the denominator. So we are multiplying to denominator by b square. So that's why multiply to numerator also by b square. So in the numerator we will get ab square, and in the denominator we will get b cube. Here plus into minus will be equal to minus, and 3 into 2 will be equal to 6. What we are getting? A into h will be equal to ah, and in the denominator b into b is what? B square is there. But what we will require in the denominator? B cube. As it stand, b square is in the denominator, we will require b cube, so we have to multiply to denominator by b. So to get what? B cube. And since we are multiplying to denominator, so that's why we are multiplying to numerator also by b. So now we are able to cancel b cube from the denominator of both sides. So here remaining term is minus 8h cube is equal to a square b plus a b square minus 6abh. So already we have got such type of expression. Just remaining part is to rearrange the term. So therefore keep this term a square b as it is, plus a b square also as it is. This minus term on this side will become plus 8h cube, and this plus term on this side will become, minus term on this side will become plus, means 6abh. Just we are using transformation. So this minus term on this side will become plus, and this minus term on this side will become what? Plus. And we can observe that this is nothing but the result which we have to prove using which condition? Slope of one of the line represented by this homogeneous equation is square the slope of another line. If you will observe this expression, how many terms appears in this expression? 3 terms. Which 3 terms? A, B, H. If you will observe both the side, this equation we are able to use as a shortcut method while solving the objective type question. But when this condition can be applicable? If slope of one of the line is square the slope of another line, means if homogeneous equation is given to us and 2 values are given, which 2 values? Either AB is given and H is not given, or AH is given, B is not given, means if any 2 values are given and we have to find out third unknown value, at that time we are able to use this equation only if slope of one of the line represented by homogeneous equation is square the slope of another line. Now see the example number 20. In this example we have to prove that the product of length of perpendicular drawn from this point to the lines represented by this homogeneous equation is given by this formula. So now we know that homogeneous equation represents what? Pair of lines passing through the origin. So these are 2 lines represented by this homogeneous equation and passes through what? Origin. And perpendicular distance of this point from these 2 lines. Let us denote the perpendicular distance of this point from the line first by d1 and perpendicular distance from line second by d2. And now we have to prove that product of this perpendicular distance, again observe the example, product of the length of the perpendicular, means length of perpendicular means what? Distance of the point from these 2 lines. We have to find out product of this perpendicular distance, and we have to prove that the product of perpendicular distance is given by what? This formula. So hope the idea about given condition and what we have to prove is very clear to you. Now we are supposing that let m1 and m2 be the slope of the line represented by this homogeneous equation. So if we are supposing that m1 is the slope of first line, then we can say that its equation is y is equal to m1x, because we know that if line passes through the origin, at that time constant term in the equation is absolute absent. If we are denoting the slope by m1 and m2, means easily we are able to find out equation of these two lines, and once the equations are known to us, we are able to find out this distance also, and once distance is known to us, take the product of these two distance and try to get our required result. Okay, so here as we are supposing m1 and m2 are the slopes of line represented by this homogeneous equation, then first write down the result related with sum of slope and product of slope. What is m1 plus m2 is equal to minus 2h upon b, and product of slope means m1 into m2 will be equal to a upon b. Since m1 and m2 are the slopes of the line, so using this formula we are able to find out equation of the line, and equation of the lines are, what is the equation of first line? Y is equal to m1x, and equation of another line is y is equal to m2x. What is m1 and m2 are the slopes of the lines. So once equations are known to us, write down this equation in standard form, means in general form. First write down the term of x, that is m1x plus y, on this side will become minus y, on this side write down 0. So here also plus y on this side will become minus y, and remaining term on this side will be equal to 0. So once the equation of both the line is known to us, what is the equation of first line? That is m1x minus y is equal to 0, and equation of second line is m2x minus y is equal to 0. So now we have one formula to find out distance of a point from the line. If equation of line is ax plus by plus c is equal to 0, then in the numerator write down the same equation, only replace x by x coordinate and y by y coordinate divided by under root a square plus b square. Means this formula is applicable to find out distance of a point from the line. Same formula we are applying here to find out these two distance. Let us denote the distance of this point from these two lines by d1 and d2. So here let d1 and d2 are perpendicular distance, of point P, whose coordinates are already in example denoted by x1, y1 from these lines. So therefore d1 into d2 is equals to, so therefore d1 into d2 is equals to, means we are finding product of this perpendicular distance. So first we are finding value of d1, means perpendicular distance of this point from this line first, applying this formula. So first write down the equation of line in the numerator as it is, only replace x by x coordinate means by x1 and y by what? Y coordinate. Means what we will get here, m1 x1 minus y1 divided by under root a square plus b square. A means coefficient of x. What is coefficient of x here? m1. So a square means m1 square plus b square. B means what? Coefficient of y. What is coefficient of y here? minus 1. So square of minus 1 into, again second equation is m2x, but x we are replacing by x coordinate means by x1 minus y1, y we are replacing by y coordinate of that point, divided by under root a square. Here value of a is m2 and value of b is what? minus 1. So here we will get m2 square plus minus 1 square. So which is equals to, now take the multiplication of these two terms in the numerator. Let us see what we'll get. First I am multiplying by m1x to both the terms. So if we are taking this multiplication, we will get m1 m2 x1 square multiplied to the second term minus m1 x1 y1, then multiply by minus y1. So will be equal to m2 x1 y1. Minus into minus will become plus, and y1 into y1 will become y1 square. In the same way, we are taking product in the denominator. So already we know that root a into root b can be written as root ab. So what is the value of a here? m1 square plus, what is square of minus 1? Will be plus 1. into here what we will get m2 square plus what is square of minus 1 plus 1. So which is equals to in the numerator m1 m2 x1 square, keep it as it is. If you will observe these two terms, can I take minus common from these two terms? Even parallelly we are able to take x1 y1 common from these two terms. If we are taking minus as well as x1 y1 common from these two terms, here remaining term is m1 and here remaining term is plus m2 because we have taken minus also common. Plus y1 square, keep it as it is, y1 square as it is. Simplify the denominator. Now we are taking multiplication of these two terms. First keep this under root as it is. Now I am multiplying by m1 square to both the terms in this bracket. So first term will be m1 square into m2 square will be m1 square m2 square. Then m1 square into 1 will be equal to m1 square. 1 into m2 square will be equal to m2 square and 1 into 1 will be equal to 1. Just simply we have taken multiplication of these two brackets. So now in the numerator, now we are not disturbing to numerator. First we are simplifying this denominator. m1 m2 x1 square as it is. See, lastly we have to substitute these values of what m1 into m2 and m1 plus m2. So we are trying to arrange the term in numerator and denominator in the form of what? Product and slope, because these two values are available. So here already first term is in the form of product, second term is in the form of sum. So not necessary to simplify what? Numerator. Now only the remaining part is to simplify the denominator. Here already this term is in the form of what? Product of slope. m1 square into m2 square can be written as m1 into m2 whole bracket square. But now this term, we does not have the value of this term because here value of m1 square plus m2 square we will require, but this value is not available with you. We will have the value of m1 plus m2 and m1 into m2. So we are trying to express it in the form of sum and what? Product. For that purpose we are using one identity. So try to understand that identity. Which identity we are applying here? A plus b whole bracket square is equal to a square plus b square plus 2ab. Now this equation can be written as a plus b whole bracket square, keep it as it is. This plus term on this side will become minus 2ab. Remaining part on this side is what? A square plus b square. Now in our equation such type of term appears. A square plus b square means m1 square plus m2 square, and which can be replaced by what? A plus b whole bracket square means what? m1 plus m2 whole bracket square minus 2ab. A means what? m1 and b means what? m2. Minus 2, sorry, here minus 2 m1 into m2, and this result we have obtained using this identity. So we have replaced m1 square plus m2 square by m1 plus m2 whole bracket square minus 2 m1 into m2. Lastly keep this plus 1 as it is in the denominator, plus 1 as it is. Getting it? Now check that all the terms are in the form of product, sum and product, isn't it? In the numerator also terms are in the form of sum and product and sum of the slope, and we will have the values of sum of the slope and product of the slope. To apply these values, we have just arranged the term in the form of sum of slope and product of slope. Now we are substituting the values. So which is equals to m1 into m2 I am replacing by its value a by b into x1 square, keep it as it is, minus m1 plus m2 replace it by its value minus 2h upon b into x1 y1 as it is plus y1 square also as it is. In the denominator under root keep it as it is. Now substitute the value of m1 into m2. What is the value of m1 into m2? A upon b. Keep this square as it is plus what is sum of slope? Minus 2h upon b. Keep this whole bracket square as it is minus product of slope is a upon b plus 1. Keep it as it is. Okay. So which is equals to, now observe the numerator very carefully. Try to understand now. So here what is the denominator? B. Here also denominator is b. To arrange b in the denominator we have to multiply to numerator and denominator by what? B. So here just we are trying to arrange b and to arrange the b in the denominator of all the terms. Already b is in the denominator of first two term, just simply we have to arrange b in the denominator of what? Third term, so that denominator of all the three terms will become same. So what we will get here, a x1 square minus into minus will become plus 2h x1 y1 plus, here if we are multiplying to numerator by b, so in the numerator we will get b y1 square and in the denominator we will get b, means denominator of all the three terms will become equal. Now try to understand simplification in the denominator very carefully. So already there is one root in the denominator, so keep this root as it is. Now, what is the denominator of first term? B square. What is the denominator of second term? B square. So we are trying to arrange b square in the denominator and here also b square in the denominator. So if the denominator of all the terms will become same, so easily we are able to take the addition of numerator. So here what will get? A square. Here square of minus 2h will be 4h square. If minus, keep it as it is. If I am multiplying to denominator by b, because we are trying to arrange b square here, so if we are multiplying to denominator by b, so multiply to numerator also by b. So here we will get ab. Sorry, here keep this 2 as it is. We have forget to write down what? 2. And here to get b square in the denominator, we are multiplying to numerator and denominator by what? B square. So in the numerator also we will get b square and in the denominator also we will get what? B square. And since denominator of all the terms are same, we have taken addition of what? Numerator. Okay. Now observe these terms very carefully. Keep this 2 as it is. So minus 2, because here 2 is there, we have forget to return this 2, so 2 is there, so here we have got minus 2ab. So now keep this numerator as it is, which is equals to, we are not disturbing to numerator. What is numerator? Ax1 square plus 2h x1 y1 plus b y1 square divided by b, keep it as it is. So now we are simplifying to this denominator. In the denominator, observe these three terms very carefully. A square minus 2ab plus b square. A square minus 2ab plus b square. Can I say that it is nothing but value of a minus b whole bracket square? Just we are collecting these three terms. A square minus 2ab plus b square is nothing but a minus b whole bracket square. Keep this plus 4h square as it is, plus 4h square as it is, and this b square outside the root will become what? B. Now cancelling b from numerator and what? Denominator, check that we will get our required result or not. This is the remaining term in the numerator and this is remaining term in the denominator. In this way we have got our required result. So and this required result means what? It is the product of what? Perpendicular distance of this point from the lines represented by this homogeneous equation.